Good evening, sir.
अच्छा लिमिट्स कंटिन्यूटी स्टार्ट करना है ना इन द लास्ट
Sir,
क्लास
can you hear me?
hmm
Sir, can you hear me?
yes yes
Okay.
limits and continuity will start na see I think continuity is not there in your syllabus, only limits is there na.
Yes, sir. Limits and derivatives.
Okay.
Derivatives part I know. Only I want to learn is limits.
Derivative part you may be knowing, you already told me. We have to learn the concepts of limits. See, actually limits, why we use the limits, you need to understand this one. Whenever we have a situation like this, hence there is a graph, this, and what do we mean by limits means whenever we have a graph like this of x is y is x, y is equal, you have to find out through limit what you are doing. You are, when we say limit x is tending to a f of x, this means what? You are trying to find out the value of f of a, f of x, when x reaches to a. Okay, this is x is equal to a position. When x reaches to a, what will be the value of f of x? That's the meaning of limit. Okay, obviously
Okay, sir.
you know that x is equal to, at x is equal to a, if you want to find out the value of f of a, that means what? You have to put the value of x is equal to a in the f of x, you will get the value of f of a, which will represent the y coordinate of this point. Correct? This is a comma f of a. Correct?
Yes, sir.
Now you will be confused, you will be thinking why it is, why we are doing, why we are putting like this limit extending to a f of x, when we can easily put the value of x is equal to a and then find out the value of this f of a. Yes, we do this operation of limits because sometimes actually x is tending to a, it may be, we may be reaching to the place a at x is equal to a from the left side or from the right side. And why we are actually doing the limit in such a way that x is tending to a or x is tending to a minus, like that, because this graph, the graph, later you will learn this graph is actually looking like continuous. Continuous means no breakage. But in class 12 you will learn that the graph will not be always continuous. It may be like this, means it will have some breakage like this, breaking at this particular point. So if the graph is broken at some point, then
Yes, sir.
you won't be able to find out the value of limit at x is equal to a. In that case, you will have to find the value of the limit, means value of the f of a at a point just left to a and at a point just right to a.
Okay, sir.
That is why, because we have to take into account all the graphs, may be broken or continuous or without broken. We have to take into account all the types of graphs. That's where we have introduced the concept of limit. Now this thing that I have told you is actually not necessary for solving questions. The only thing that is
Yes, sir.
necessary for solving questions in your examination is you have to know that when we are writing limit extending to a f of x, what's the meaning of that? Normal way, you have to just put this value a in place of x. That will be your answer. Okay.
Okay, sir.
Critical part will come in class 12. Now, once we have learned this concept, there are certain rules and properties of limits that you need to understand before solving. Properties of limits. What are those properties of limits? When we have a situation like limit x tending to a, f of x plus or minus g of x, then in that case this limit goes inside and applies individual to each function. F of x and g of x are different functions. Then this will be equal to, I'll give you an example, don't worry. F of x plus or minus limit x tends to
Yes.
a, g of x it will become. Clear? Now an
Okay, sir.
example showing this is, suppose I have given you limit x tending to 2, x square plus 2x is asked. There you can consider them as two different functions. This is one function f of x, this is other function g of x 2x. So you can just put limit on each, limit x tending to 2 x square plus limit x tending to 2 2x. Okay, like that. This is an example. If you uh, but you will think, sir, it's more easier, isn't it much easier if we just put the value of 2 inside this x square plus 2x? 2 square plus 2 into 2, we'll get the answer directly. Why to it apply individually? Yes,
Yes, sir.
but in this case the example I have given you is very easy one. This here just putting the value of x is equal to 2 will be easiest way, but sometimes actually the functions which are given to you are not easy, they're difficult. So in that case you should know that the limit goes inside, will come across. Okay, just understand the property how they are being applied. So the second part is, if we have limit extending to a, k into f of x, then this k, where k is a constant, the constant term comes outside. K, it becomes k limit extend to a f of x. Okay, understood?
Yes, sir.
Example, if we take the, this case we had na, this one limit extends to 2 of x. If we try to solve it, what it will become? 2 limit extends to 2x. Clear?
Yes, sir.
Okay, now come to third one. Limit extending to a, suppose I have two different functions which are multiplied to each other. In that case, what I do, I apply limit extending to a f of x into limit extending to a g of x. This is somewhat different. This I will mark as important for you because this is against the trend. This is somewhat different than the trend. We have only one limit that is being applied to two different functions which is multiplying each other. Then you can apply a limit individually to each function and then multiply them. That won't change the result.
How, sir?
Example I'll give you. Wait. Suppose limit x tending to 1 is there. You have x square plus 2x. Okay. I can write this one. I can just solve it by putting x is equal to 1 here. Or the other way is I can write this one as limit x tending to 1 x into x plus 2. Now this will become what? Limit x tending to 1 x into limit x tending to 1 x plus 2. Correct? So your
Yes.
answer will be what? 1 into 1 plus 2, 3. So it will be 1 into 3, 3. Now, but if you solve it by direct way, putting 1, it will be 1 square plus 2 into 1. What is the answer? 3. See, this answer and this answer are same.
Yes, sir.
But this thing, this property, the third property that I've told you, it actually helps. in complex situations in which it's not easy to just put the value and you're not getting the answer, because I'll introduce you with the other term which is indeterminate forms. In that case, applying limit individually helps. Okay, understood now?
Yes, sir.
Now coming to fourth property. This is important property, this third one, because here only the student get confused. The fourth property
Okay,
is limit extending to a if you have f of x divided by g of x, and in that case limit applies individually, means it becomes limit extending to a f of x divided by limit extending to a g of x. Example you can take is limit x tending to 2 x square by x plus 2. One way of solving is just putting the value of 2 here. You'll get 2 square by 2 plus 2. It's 4 by 4. It's 1. The other way we do limit x tending to 2 x square divided by limit x tending to 2 x plus 2. What will happen? 2 square divided by 2 plus 2. Again see 4 by 4, one answer. Answer is same. Just I'm showing you the application of property, why the property behaves such. Okay,
okay, sir.
means what actually what we understand from these two, third and fourth, the limit, whenever limit is there, it applies individually to each function. It replicates itself, multiplies, applies to each function individually. Coming to fifth property, there are no more property. Three or four, one, two properties are also there. Limit extending to a f of x whole power g of x. In that case, again, limit applies to each property. It will become limit extending to a of f of x power limit extending to a g of x. Okay. Again, limit is applying to each function individually. You want one example?
Yes, sir.
You see, limit extending to 2 x power x plus 2. If we take, we apply normally, it will become 2 power 2 plus 2. It is power 4. Now, if we apply to each one, limit extend x whole power limit extending to 2 x plus 2, it will 2 power 2 plus 2, it's 2 power 4. Easy. Now the property
Yes, sir.
actually you have to focus, you have to keep in your mind important things are property 3, 4, 5 and after that, because earlier one is common sense. Limit extending to a log of f of x is log limit extending to a f of x, means limit comes inside, limit even goes inside the log function, applies individually to the function, not a problem. Means
Okay, sir.
no one can stop limits, they can go anywhere, apply to anyone, any function. We need to give example now, easy.
Yes, sir.
One more thing is f of x is less than or equal to g of x. In that case, limit, when you are applying limit to each, then you can just write limit extending to a f of x. is less than or equal to g of x, less than or equal to limit extending to a g of x. So now the properties are done. Let me give you some questions. Actually, usually what is there, na Kanishka? There are actually standard formulas, that you should remember while solving a question. Just I'll give you those formulas. These will be enough. Four set of formulas. A few formulas I have listed here. These formulas they are actually used for solving the questions. But before that, these formulas, you'll make use of these formulas later when solving the complex questions. But I'll give you the short trick also, to if you do not want to remember these many formulas, how to.
Okay, sir.
Let's start solving. Just try to solve this one easily. Uh, Question, this is very easy question. You'll be able to solve. Solve limit extending to 1 x cube minus x square plus 1. First one. The question is limit x tending to 3 x into x plus 1. Other question is limit x tending to minus 1 plus x square plus and so on up to x power 10. Try solving them, giving me answer.
Okay, sir. So could you solve the first one and the third one? I got the answer for the second one.
First one you did not solve. Easy now. 1 cube minus 1 square plus 1.
Wait,
1 minus
is
1.
zero? Zero is allowed. Oh,
No, it's not
one.
0. No, 1 is the answer. But 0 is also allowed. It's a finite value. Na? Why
But
0 is?
sometimes as a denominator, it's not allowed.
These are indeterminate forms. It's 0 by 0.
Oh,
0 in the
my mind
denominator.
got stuck
Uh,
there.
0 by 0 form is not allowed. But a single 0 getting in the answer is allowed.
Okay. For second one, it's the answer is 10.
No, 3 into 3 plus 1. 3 into 4, 12.
No, it's the square there. One more x is there.
X into x plus 1. Na? So 1x is
Yeah,
3.
outside one more x is there.
Why? Where?
Here, outside the bracket.
Ah, 1 is x. 1 is x plus 1. So for x, we have put the
No,
value 3. Other is 3 plus 1, 4.
okay.
So 3
I
into
was
4.
thinking if we
So
multiply the x squared plus x.
like that also you can do if you want. X square plus
Okay,
x also you can do. There you put the value 3. 3 square plus 3. 9 plus 3. 12.
12. Okay.
Now coming to this third question. 1 minus 1 plus, acha, 1 plus x square. If you solve this, you have to add it. 1 plus minus 1 plus minus 1 square plus minus 1 cube plus minus 1 power 4 plus minus 1 power 5. You will get a trend. Okay, now this and this will get cancelled. This and this
Yep.
will get cancelled. This and this will get cancelled because its answer is minus 1, its answer is 1. Right? This and this will get cancelled,
Okay,
this and
so
this will get cancelled. Only thing remaining is minus 1 power 10, which is 1. So the answer is 1.
1.
Easy.
Yeah.
Now coming to your indeterminate form. Usually we solve the questions of limits by applying just these properties that we have learned. Like we have solved these three questions. Now sometimes what happens when we solve questions of limits, we actually get answers in different way, like these forms. Sometimes we get answers 0 by 0 form, or infinity by infinity form, or infinity minus infinity form, or infinity into infinity form, or 0 into infinity form, or 1 power infinity, or 0 power 0, or infinity power 0. Okay, if we get these kinds of answers now, they are not considered to be the correct answers for limits. They are known as indeterminate form. You were telling me about the first one, correct?
Okay, so
Mostly when you will be solving questions, you will be getting a form. You will be getting answer of this type, 0 by 0 form. If you are getting finite answer, it's okay. Your answer is that finite answer. But if you are getting this 0 by 0 form mostly, then in that case, you will have to further solve the limits using few methods. That's the methods which are there are for these. One is factorization method. Second one is rationalization method. Third one is
Okay,
substitution.
sir.
Let me tell you how each one. See, what is a factorization method? First, let me tell you this one. Take a good example of this. This one. Factorization method is C. The method is, if you have this limit extending to a, ax square plus bx plus c divided by dx square plus ex plus f, like this type. Okay. And you're putting the value a inside, and then you are getting 0 by 0 form, right? You have to identify. Suppose I have given you an example. Limit x tending to 2 x cube minus 4x square plus 4x divided by x square minus 4. Okay, just try to put the value of 2 here and see whether we are getting 0 by 0 form or not. See, if you would put the value here, na, 2, what we are getting is 2 cube minus 4 into 2 square plus 4 into 2 divided by 2 square minus 4, right? This is 8 minus 16 plus 8 divided by 4 minus 4. Upper is 16 minus 16, it is 0 by 0. We are getting 0 by 0 form, na?
Yes, sir.
Yes. Now what to do in such situations? We try to
So
factorize it.
either we could rationalize or we could factorize.
In this case, we cannot rationalize because rational forms have to be like this. Root a plus root b, like that. Root should be there. So we can factorize it. Now, can you tell me how will you factorize it? How will you create factors for this one? Denominator, you can write x square minus 4 as x minus 2 or x square minus 2 square, which can be written as x minus 2 into x plus 2. How I'll write numerator part? X cube minus 4x square plus 4x. How I'll write in factorized as factors? Take some time and give me. What happened? Are you able to do it?
Yes, sir. Solving.
Okay, do it. Okay. See, it's x into x square minus 4x plus 4. You can write this as x into x minus 2 whole square, na? How much time you are taking? Anishka?
I was calculating the final answer.
X into x minus 2 whole square, na?
Yes, sir. That's what I got. I thought I did some error.
Mhm. See, now why this helps actually? Now this, the question that you had, you have created factors. Now in the method, you can actually cancel out the common factors like x into x minus 2 whole square divided by this x minus 2 into x plus 2 is there. So you can cancel out the common factor. This and this is cancelled. Now our limit will become limit x tending to 2 x into x minus 2 divided by x plus 2. Now see whether you are getting the 0 by 0 form, because it's 2 into 2 minus 2 divided by 2 plus 2. It's 2 into 0 divided by 4, which is 0. You're getting a finite answer. It's not 0 by 0 form. So this is your answer. In the factorization method, actually what we do, we create the factors and fi- we simplify this expression in the form of factors, and then we try to cancel out the factors in the numerator and denominator, common factors. We try to cancel out the common factors. Understood?
Yes.
Now, can you solve one question I'm giving you? Try to solve this question. Even see, one more thing is, even in this case, you can get infinity also. 0 and infinity as the answer are acceptable. I'll give you an example, don't worry. If you get an answer as 0, that's acceptable. If you get an answer as infinity, that is also acceptable. But 0 by 0 form, yeah, infinity by infinity form is not acceptable. The question that you need to solve is now, limit x tending to 2, x cube minus 2x square divided by x square minus 5x plus 6. First check whether it is 0 by 0 form. If it is 0 by 0 form, if it is coming 0 by 0 form, then try to factorize it, create factors, and then try to cancel out the common factor from numerator and denominator.
Okay, sir. Sir, it's 0 by 0.
It's 0 by 0 form, na? Correct, very good. Now try to factorize it. Create factors for numerator, create factor for denominator, try to solve it.
Okay, sir.
Correct? Kanishka, you try to solve this question at home.
Yes, sir.
Take it as a homework. If you are
Okay,
not
sir.
able to solve, I'll solve in the next class. Bye bye.
Bye, sir.